Good evening, everybody. So, today we are going to do a few things. First, we're going to modify all of these cylinders. I have already modified two of the switches. And of course, I have modified lift arms. Oh yeah, here we are. Yeah. So, we're going to modify a few switches that we need for the engine. These are for a customer. I have already modified the lift arms. And I have already modified two switches. So let's first do the big hello. Let's first do the big cylinders. Come on. Yes. I'm gonna first open up all of the cylinders because this is the most tedious work. So let's get this out of the way. Okay, the big ones are done. Hello, Marcelo. Big ones are done, and now let's do the small ones. With the small ones, you have to be extra careful not to damage these clips. It hardens extremely fast. It's I use this. It's it it's almost immediately hardened. So while our other streams were made with unmodified bricks, today we are going to do A lot of modifying as a change of pace. Okay. So the tedious work is done. Now we have to remove all of this gunk. See? This goo that Lego puts on. All of this needs to go. Hello. Hmm. Focusing. The camera thinks the background is more important than the foreground. Oh my god. Look at this beauty. Ew. So most of the cylinders I get are used because new ones are often so expensive that it's crazy. Well, the bigger one are specifically for a customer that ordered cylinders, and the small ones are for our engine, which is also for a customer, but doesn't matter. There we go. That's much better. Okay. Of course, we need to clean the insides of these as well, because they are often dirty, and there's residue of the gunk. Yeah. Sometimes there's less of the gunk inside. Sometimes a little bit more. Sometimes when you buy used cylinders, come on. When you buy used cylinders, you get this. So this needs to be replaced. Oh my god, look at this. This is complete garbage. I don't know what people are doing with the pneumatic cylinders. I mean, this is rust, or what is this? Yeah, that's rust. I mean, how? How do you get rust on this? Yeah, but paper is not good. Paper will get destroyed immediately. Come on. Okay, so two more. Yeah. This one wasn't too bad. And the last one. No, that wasn't too bad either. So we need to decide what to do with this one. I think it's junk. This one's junk. But that's always a risk when buying used cylinders, since new ones are so expensive that I don't even make any profit on it. Not only profit. If I bought new ones, I would basically take a loss. It's just makes no sense. And good used ones are perfectly alright. You are welcome. So let's see what we can do about it. Okay, I do have some spares. Now let's see. All of these are junk as well. Let's see if any of the cylinders have some that look better. No. That might be passable. Passable. Hello. Passable. Yeah, that one is also passable. So we have 3 passable candidates. The E30 has been reduced to its components. Okay, need to clean those as well. Well, I don't really. If you are the one who sent me the friendship request, I don't really accept friendships from people I do not know. Like the LP Power page, that's fine, but a friendship is something else. I hope you understand. It's nothing personal. Okay, now we need to clean the insides. If you like the LP Power page, you can also send me a message. So don't worry. You can send a message via the LP Power page. Nah, don't be sad. We can always rebuild it. We have all the pictures. But if I did it again, it would be better. Oh my. This one is quite nasty inside. That's the rusty one. That's done. Now let's see about replacing this one. I think this one looks best. Um, will you be surprised that I have no idea what the pricing for those is on my page? What do you mean next project? We need to finish this one. Before we finish this one, there's no next project. There's ideas, of course, but I have posted a video on the LP Power Facebook page from Donut Media, where they drove the no, come on. They drove a modified version of the Chiron. They tried to make it go as fast as possible, but it ended in a crash. So I reckon I can make a better version of it, a much better version, and have it not crash at the end. But the problem is that I don't have a. Yeah, that's Corona, of course. The problem is that I don't have the budget for it. A project like that would cost me easily, I don't know, 800 to 1,000 euros, which I don't have lying around for a Lego project right now. Alone, the electric motors required for it, which would be the black buggy motors, would cost probably 300. Yes, we are planning on putting a 3-speed manual transmission in it. Okay, so yeah, we're building a dot charger. That's the current project. It needs to be finished first. Then we're going to talk about future project. The leaks are not because of the hose. We are going to show, I mean, probably one of those, at least one of those cylinders will have a leak. And I'll explain why the leaks happen and what to do about them. So drilling holes does not cause the leak. Wait, what? Oh man, really, I forgot to drill this one. How does this happen? That's the only one I forgot to drill. Oh well. So that's more like it. Yeah, they are. So I bet at least one of those will have a leak. At least one. Okay. Let's clean them up a little bit because they are just filthy because of the grease. And then let's test them to see if they are any good. What do you mean? The charger will have a fake Lego engine, but it will have a fake Lego engine that is actually good. Not we're not going to make one of those standard Lego engines, but I want to have a camshaft, push rods, and valves. We're just playing with Lego. Nothing to see. Move on. Okay, so let's test the cylinders. First, the upstroke. There we go. Perfect. Now the downstroke. Perfect. Wait a minute. One more test. So I squeeze the shaft and let it pull down. So no leaks here. This one's good to go. There we go. That one's fine. See, this one is fine. That's fine. Fine. There we go. Hear that? So what's happening? Why is it leaking? I can feel air escaping here. So I'm pumping the upper compartment and the air is escaping here. What's happening? The air is going around the piston. So it's coming out here. So this one needs probably a new piston seal. Another one. That's good. That's good. Yes, the plan is for us to build a small cylinder inline 4-cylinder today. I'm just modifying the big cylinders because I need to ship them tomorrow together with the inline 4. So why not do it on stream? Okay, so we have one faulty cylinder. Let's take it apart and see what the problem is. Okay, as I expected. So, see, there's absolutely no surprise here. This piston ring is completely deformed, and that's why uh, air is passing from this compartment down here, and so it leaks. Yeah, another thing that you can experience is that this seal here, this top seal is bad. That can also happen. Or if your shaft is too corroded, then it can leak despite the seal being good. But try applying silicone lubricant and see if this will soften up the seal and help with sealing the cylinder. So we need to replace this guy here. And let's take basically a random, just a random seal. It can be worse, probably. Apply some lubricant. Put back into the cylinder and retest. So, upstroke is fine. Downstroke is fine. There we go. 8 good cylinders. And this one, yeah, I'll just put it in there. Who knows? There's none for sale. All of mine are from used cylinders. Since I had so many cylinders go through my hands, the all of the good parts are kept for spares, and the bad cylinders and seals are in the cylinders that are used for springs. So the cylinders I use for as shock absorbers don't need to be perfect. So I use the parts that don't seal in them. That's the whole story. Every time you go through a lot of these, you inevitably end up with spares. So, small cylinders. These are usually not so nasty because there's less room for goo. Yeah, that's fine. I basically just clean them up as best as we can. Yeah, but pneumatic cylinders are not discontinued. They are still being produced. They're just expensive. So we just need 4, but I'm going to modify all 5 of them because why not? Okay, this one is the nastiest. Yeah, but I don't know. Have you seen Chinese Lego reproductions? I mean reproductions. Their version of Lego. I had I bought for Christmas. I bought my niece. I don't know which exact brand it was, but the gripping power and the overall quality was not on Lego's level. So whatever you think of Lego and the color variations, the quality of their parts is still on pretty much on top. I mean, Kobe, the Polish manufacturer that mostly makes military stuff, um, they have a very good quality as well. But differences to Lego are still noticeable. It's not 100% as good as Lego. Okay. They probably would leak, yeah. What the fuck? Okay. I need a sharper drill, I guess. Oh, this one's already drilled. This one's already drilled. Okay. This one's not. Let me just check the condition of this one. Ah, this one's already drilled as well. Okay. So what? Why would you? Why would silicon or my skin make me ill? I don't get it. Okay, this one is already modified. Very nice. Okay. So these are drilled. Let's greasen them up. Come on. There we go. Ah. This one doesn't want to sit right. Let's see why not. Define a version 1 and version 2. There's many versions of cylinders. Okay. This one is disqualified because the shaft is bent. Yes, this is an engine building episode. I hope this is alright. I said in the previous stream that we are going to build an engine today. So we have 5 good ones, and this one has a bent shaft. So I'll use this one. Come on. It's actually not to hold the hose better. It's so that the hose slips on better. Ah, okay, yeah. Yeah, there's at least 3 versions, or 4 if you count the first ones that had a yellow cap. Those were the first ones in 1989, I think. Okay, testing time. Let's see. There we go. That's fine. No, that's why I use the hard plastic hose. Okay. That's good. Fine. Okay. Yeah, that's fine. So any of these 5 are good. Let's take randomly one out, and these 4 are the ones that we are going to use in the engine. So we have switches, we have modified conrods. We need to still drill these. Yeah, I use hard tubing like this. This is actually tubing that needs to be bent on a candle, which is what we are going to do today as well. So I'll show you what I do. But first we need to build the engine. Yeah, the hoses easily pop off under load, so that's why I don't use the silicone tubes at all. Because the last thing I need is a hose to pop off at the least convenient moment. Oh look, this one is already drilled, so that's fine. Okay, so no more drill required. Let's go on to modify more parts. Yeah, but you know that would not be Lego anymore. I could do it, but you know everything's possible. Depends how much you want to stray from the source material. No, I never use any computer-aided design because all of the all of the programs to design with Lego suck, to be honest. They are maybe okay for someone building pre-existing model, but if you want to check all of the clearances and stuff like that, you really need to do it hands-on. So what we need to do is, on those 6 gears, we need to get rid of this edge and this one, so it will be just this thin gear left. And that's why my desk is in such a condition. There we go. Before, after, that's what we need. And we need 6 of them. Well, problem is that I actually want people to replicate my models, or at least my models need to be accessible. So if I stray too far away from what is actually Lego, so official Lego parts, I don't know. At this point, you can really design a model from something else. What you're building is not Lego anymore. That's what I meant. It's all feasible, of course. Yes, you can do it. Yeah, exactly. It forces you to think and to make. It's like a puzzle. That's what's fun. If you had the infinite power to make any part you wanted for that specific for your specific need at that moment, that's not the idea. The idea is that you make complex models from what's there. Yes, what we are cheating a little bit with modifying the parts here, but we are modifying existing pieces, not creating new ones from scratch. Modifying stuff like this in huge quantities is the most boring part of any Lego build, if you ask me. I would much rather uh, just have everything made out of parts that already exist. But as you will see in this particular instance, this is necessary. Two more. Two more and we're done with this tedious task. Only one more part no, If we forget about gluing parts, there's just two more parts that we need to modify after this. So one more. Yeah, it's injection molded. It's ABS plastic, probably. Just standard ABS plastic. They probably add some I don't know, some mix to it, but nothing special probably. Yeah, ABS I think it is. They do use a very quality version of the plastic, but still the color variations are, I don't know. They were, let's say it like this. They were not present in the 80s. Yes, there were fewer colors, but if you had red, there were no 50 shades of red. It was just red. So something has changed. Okay, that's done. Uh, Now you will be surprised that you're going to be surprised that I don't know all of my models by heart. Some things I made specific photographs of exactly so I don't have to remember. And it's the same with the engine. Okay, this is what I need. So we need an axle that is 1, 2, 3.5 long, and the other one is 1, 2, 3, 4, 5.5 long. Okay. Yeah, more pneumatics would be good. I support that. Absolutely. So 5.5 and 3.5. Okay. Sorry, I'll do it here on the edge. It's much better. There we go. Oh my god. Yeah. I cut myself on camera. Oh god. Let me just bandage myself so I don't bleed out here on camera. Cutting Lego is dangerous. Let that be a lesson to you. No, I don't. So, back in business. All right. Yeah, it'll be fine. No big deal. By tomorrow, it's going to be healed. Okay. So, what we need to do now is I glue these two parts, this part to the half bush, uh, because if I use two parts, two gears that are two stock 16 tooth gears, uh, we get misalignment. And let me show you. Yeah, Lego is very dangerous if you modify stuff. So let's see why we are modifying parts. Mhm. So let's take these two. So we have a normal 16 tooth gear, and then we try to add another 16 tooth gear so that the axles are completely parallel to each other. What we can see is that the teeth clash. So this is no go. What we need to use is this combination, and that's why I glue uh, this guy to the axle so that we maintain uh, the parallel uh, position of the axles. Okay. You missed an accident. Not much else. Come on. Yeah. And the short one is here. We are building a small cylinder inline 4 on the stream. That's what we're doing. So this is good. Let's check. Needs some modification. Let's not repeat the previous mistake. Okay. Yeah, that's better. Okay, so this one does not need modification, and this one does. So we are gluing this to the what's this called? Come on, to the bush. But for this we need this exactly. Come on. There we go. So the axles are aligned. Now it's super glue time. Okay. We're going to reinforce it a little bit still by applying some glue here. Yeah, there's many YouTubers do make LPs. Okay. Okay. There we go. It's already glued. Okay. What do we need now? We need more parts. We need this. And we need two more of these. This and this and this. Then we need this. 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 cam lobes, which are these. It's 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, and 3. Okay. Then we need axles, and then we can build this. So this. There we go. Of course, that is also what we need here. And another 3 axles. Okay. So. I'm so stupid today. It's like this, of course. This, and this. There. That's a no-go. There we go. See, the reason we need to do this is because we want the cam lobes to be parallel. Otherwise we get funky timing. And we do not want funky timing. There we go. No, really. So, our camshaft assembly is done. What do you mean? How much RPM can I have? I know how much RPM the Inline 4 produces, approximately. It's always an approximation because the quality of the cylinders, the way I modify the switches, it all has an effect on the way from what kind of engine. I can get about close to 5,000 at 10 bar from the inline 4. I have no idea how much 10 bar is in PSI though. Okay. More parts. So now we need 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, that's too much. 2, 2. Yeah. Okay. Axles, we need fiver and 4. And then, oh yeah, of course, we need more axles. We need 2 of these, and then we need 1, 2, 3, 4 of these. Okay. Yeah, I guess that's how much PSI you need. Good question. I actually came up with this color scheme because it goes blue goes very well with light bluish gray, and I like it. There's really no other reason. I could use any color combination. I actually, if the customer wants it, I can do any color combination that is that you can buy from Lego at a reasonable price. But sometimes you just do not find the parts that you want on Bricklink, and when you have to buy bricks from 10 different sellers for just one engine, it makes absolutely no sense. So okay, now we are going to glue the crank, because the crank is really the most stressed part of the engine. I prefer really to glue the whole thing. I mean, I glue sections, so the crank really needs to be uh, disassemblable, but a few sections are glued together. Let's leave it to dry. Okay. Now there's the middle parts. I prefer to assemble them first. Otherwise, I just confuse them, and the result is chaos. I always prefer to check that the axles are parallel. Otherwise, you can get wobble, and that wobble will take away valuable RPMs, which we do not want. I use Loctite. It's super glue for all intents and purposes. So where are there? Not this. This. Okay. Let's see. Depends on the tune of the engine. The RPM is about a little above 4,000 and up until 5,000. Okay. This, and then we have this, and this. Okay. We do know, to be honest. Okay. Okay. That's how it's going to be. So now I drop some super glue here. Make sure it's flush, and then see if it's as parallel as possible. Okay. Well, preferably you should not get super glue on your fingers. How did you make it run on hydraulics? I mean, for hydraulics, you need to have a closed circuit. Ah, okay. I get it. Yeah. Yeah, of course it runs slow because water is much thicker than air. That's to be expected. I mean, water does no harm to Lego, so that's fine, I guess. Okay. Let's see what else do we need to modify. Okay, we need to modify the switches. I hope you don't mind me doing all this boring gluing and preparing stuff. I can imagine it's a little bit boring to watch. So I'm sorry for that, but that's what it takes to build an engine. Not everything is glamorous engineering. There we go. The problem with old switches, I mean, there's numerous problems. First of all, they're hard to get. Second, they are extremely brittle. The material they are made of is extremely brittle and it tends to crack. And to be honest, gluing various bits to the new ones uh, makes them actually more versatile. It's actually much better to use this technique than to modify the old cylinders. The old switches, sorry. Just noticed my mistake. No, it's not really interesting. That's how it is. That's how it is. I mean, I still have old ones if I wanted to use them, but I don't. Okay, switches are modified as well. I have them, but I opened one and quickly saw that there's absolutely zero potential for modifying. I tried, but there's too much. There's too much wiggle room. The closest I came to jigs is this. I made this jig. This jig is for gluing the cylinders for the V engines. The switches for the V engines, and this one is for the switches of the big cylinder inline 4, but I still prefer to do it by hand. I get all my parts from Bricklink. Where? You mean on the switch? I cut I cut off one of the studs. You'll see why. It'll become apparent when the engine starts to take shape. So of course, because I can't remember shit, I make pictures like this, so I can remember how to put the engine together. Well, Lego never considered that crazy people like us would make Lego pneumatic engines. That's one of the reasons. So now I'm missing a few of these, so I'll have to cannibalize the Charger rear suspension for them. But don't worry, we are going to replace them with black ones, for example. Luckily, we made all of this very modular. Come on. There we go. Come on. Go apart. There we go. So yeah, if anybody was missed yesterday's episode, this is where we ended up. So our beautiful rear suspension of the Charger with leaf springs and a very sturdy differential. But we don't need this today. Like this. So 1, 2, 3, 4, 5, 6, 7, 9. Okay, we need 1, 2, 3, 4, 5, 6. There we go. And then we need how many? 1, 2, 8. These. The differential is from the Top Gear remote control car. All in all, a very forgettable model, but the differential is amazing. Okay, we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 times this one. Oh yeah, 3 more. 1, 2, 3, 4. There we go. This. And now we need a whole bunch of connectors and axles. Okay. Right. Let's start with connectors first. Just put some out here. Oh, you were the one who ordered the wheel hubs. Yeah. We can make them on the stream if you like, but not today. Today we are going to run out of time probably, but maybe tomorrow before we start with the Charger. So we need 1, 2, 3, 4, 5, 6, 7 of these. 7 of these. And then we need 1, 2, 3, 4 of these. count them in? No, I counted those in. Okay, then we need 1, 2 these. There we go. Yeah, it's no rush. Just saying. For the entertainment of everyone, we could do it on stream. If that's okay with you. If not, I'll do it off screen. Okay. I prefer to lay out all of the of the components of the engine, and then we just put them all together, and suddenly we have an engine. So the build-up part is a little bit boring, but then it's fine. Hello, Jan. Is Finland enjoying a hot summer? But okay. Now we need a few of these. What else do we need? At the moment, this will suffice. Okay. No. Wrong one. I think we are going to go for another hour. I hope that by then we have at least all the mechanical bits of the engine done. Which should be, I mean, the engine will come together pretty quickly now. Okay. 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 There we go. Okay. Now we can start assembling this. go. Back side of the engine. Now the front side of the engine. Front of the engine. I love this. Okay. Then we use this one. And this. Okay. Front panel of the engine. Now the middle ones. Okay. Number one. Number two. The same one as the number one. And now the middle one, which requires yeah, okay, doesn't require anything extra. It's just like this. Oh, yeah, I guess it's like this. Just a simple. I have a feeling that I will have to redo this because I have not taken enough pictures. Okay. Okay. Center section. Okay. Now all we need to do is make the side supports for the cylinders. This side is pretty easy. There we go. And now the most complicated one. always try to orient the pieces so that they have the same orientation, and the mold markings are pointing in the same direction. Okay, this one's, and now okay. My God, it's so complicated. I'm forgetting how it's done myself. And then all of a sudden we are going to be presented with an engine. Okay. Okay, we need to cannibalize something again. Let's see. Okay, we do it like this. What do you mean, rods? Wait, what? Why am I doing this? I have enough. There we go. Okay. The final piece in this puzzle here are the side the balance shafts, so called. So the balance shafts run on each side of the crankshaft and prevent it from twisting. So what do we need for the balance shafts? Yes. These are part of the balance shafts. And then we need this one. Okay. And then we need two. Then these, and Thibaut, what rods? I have no idea what rods you want to put in the engine. So here's where the other part of our thin gears comes into play. Like this. And this. Oh, the black bars. The black bars combine two 4-stud pins, two stud pins into one 4-stud pin, if it makes any sense. So one of the balance shafts is done, the other one, and then we are ready to assemble the engine. Ah, one short. There we go. Okay. One more thing, as usual. I think we need this axle. So. Well, the problem is the tubing, which will take some time. I'll do my best. Yeah, I modify them for better airflow because, you know, if we modify everything, we modify the small cylinders as well. And I'm pretty sure it actually helps a lot. So. Okay. Then we have this one. the assembly itself is a little bit of a mess, I'm afraid. Okay. Oh, I fucked up. I see it now. Okay. I need to make another piece here. Of course. I mean, I made all of the pictures that are necessary, but still. Oh well. Okay. And just let this sit for a few seconds. Okay. Ah, of course. Need not forget this. Now it's this. Go. Okay, and now it's this. Okay. Okay. So this stage. Now we are going to install this guy. So everything goes out. I use plastic tubes, yes. They are different than Lego silicone tubes. Okay. So of course, like this. I knew it. I knew it. I fucking knew it. Okay. What have I done? Oh. That's right. My God. Okay. That's not right. Okay. Let's check again if the crank is correct. Yeah. The crankshaft. Looks alright. So this is okay, this is okay, this is okay. Yeah, okay. That's alright. Now we put in the first side of our guide. Like this. And I'll just use one of these gears. Check this. Oh my God, really. have I done to deserve this? This is, of course, wrong. Needs to be like this, of course. Okay. Where did we go wrong? Yeah. Obviously, it was right the whole time. Hey, boss. I have built so many of these and still I get it wrong. And it would be fine if I would get it wrong a few times. I get it wrong every single time. And I don't know why. Anyway, so. Thanks. Thanks. Nah, that's not being old. I mean, that happened to me uh, before. Before I was old. So, that's no excuse. Age is no excuse for that. Come on. These are so difficult to get in because they have so much gripping power. Come on, sit inside. So, these guys in. Now the other guy. Of course. This because design changes that I was not informed about, aka I didn't make pictures. Well, I'm not exactly showing you how to build it. You're not really going to be able to build it from this stream. Okay. Now I need to put this. Oh, okay. Thing is, I have problems building it on the stream, so there's that. And it was at this moment that he knew he fucked up. Yeah, there's that. I'm really sacrificing myself for your enjoyment. Forgot parts again. My god. Okay. How satisfied are you with the engine, James? That I would like to know that. Okay. Did it fulfill your expectations? Does it run? Does it still runs good? Very nice. I think this is a very nice little engine. The sound it makes when it runs at high RPMs is excellent. Ah, come on. Okay. Okay. There we go. There we go. So, we're not done yet. Let's continue. We need to install switches. So the switches, in order to time them right, the switches get a bushing that will interact with the camshafts. So we're not done with drilling yet. So in order to install some of the bars that we still need for this engine, and it must be just three stuff ones. We need to drill a little bit more. I completely forgot about that. So the bar thickness is about this, and I'll show you the problem. See, we cannot. Come on, focus, focus. You see, the black connectors have a square hole instead of a round one. So we need to drill it round in order to install the bars. And it's exactly 2 of them that we need to drill. It's this one. Ah, okay. Oh, that's good to hear. Always good to exceed your expectations. And this one. So, it receives a 3-stud bar. It was 3-stud bar here. And here. Here and here. Okay. So what happens next? Next we install the switches. Switch 1. Switch 2. Another bar is here. And of course there's another bar here. There we go. Okay. Now we need connect these. Yes. Yes, I just noticed. It happens to the best of us, I guess. Okay. Reversing this one's. Parallel inline 8. I don't know. The inline 8 would have the crankshaft on the inline 8 would be too long. That's the main problem with an inline 8. But that's also why no other manufacturer other than Buick, I guess, has produced an inline 8 because and even Buick discontinued it because the crankshaft is just too long. And then with a long crankshaft, you get whole bunch of problems. There we go. A few more parts to do. A few more parts. This is good. This is good. Okay. So now let's make the front panel, and then we can time the engine. Almost tubing time. Come on. That's a difficult question. I would say the favorite engine, the most fun I had with an engine was when I developed the V8, because I had so many iterations of the engine, and each iteration was different. And I really had fun watching how it progressed, how the RPMs got higher and higher, how the whole engine worked better. So I don't know. I would say the V8. Yeah, how would I build a Wankel engine? That's impossible. At least out of Lego. There's really no good way how to make a Wankel engine out of Lego. I wouldn't even know how to make one that's just a model, so just a fake engine. Yeah. The V8 has a soft spot in my heart. I spent so much time developing it, and a lot of what I learned with the V8 was then implemented in other engines. For example, the big cylinder inline 4, or okay, or basically any other engine that I made. No, that's not gonna happen. Not that I hate Yugos. We had a Yugo, so I don't hate it, but you know, okay, timing is perfect. So there's a very particular way I time the engine. The crank needs to be on the first cylinder. It needs to be in the bottom dead center, and then the first lobe of the camshaft is about 45 degrees uh, angled. That's that's the setting where the engine runs best. It's not the highest RPMs, but the engine runs best. So most power, it runs smoothest. That's where you want it to be. Of course, if you want more RPMs from the engine, you can have that. But there's always a cost. More RPMs brings less power. It needs you basically need to help it start. Uh, Otherwise, it won't start. It needs some manual cranking. Okay. Which question was that? James, what question did you want to ask? Nice. Another modified piece needs to be manufactured. There we go. Ah, yes. There. The engine is mechanically finished. And guess what? It's tubing time. So I'll first make some order here on my desk in order to be able to work. Okay, we don't need this. Okay, but we still do need this. There's one more hole that we need to do. See, this one needs to be enlarged because Lego holes are 4.8 millimeters wide, and the tubing needs a 5.2 millimeter hole. So 5.2 millimeter drill bit, and we enlarge the hole. Nothing to it but to do it. What am I doing wrong? It's not the right drill bit. Oh, it's this the large drill bit. 5.2, yeah, that sounded strange. I don't use a chain because gears are much more reliable. The chain requires chain guides. Come on. The chain requires guides and stuff. I used chains on the V8, but yeah, on some iterations of the V8, but never again. There we go. And now tubing passes through. No, I don't have a drill press. If I had, I would use it. So let's see how we can put everything into the picture. T-joints are drilled, of course. The T-joints have enlarged holes. The tubing is polyethylene, 3 millimeters inside diameter, 5 millimeters outside diameter. But of course, it's actually 5.2 outside and maybe slightly smaller than 3. But it's perfect. It fits the inlets on the cylinders perfectly. Okay. So I always keep old tubing around, so past mistakes or just I don't know, straight sections that I can reuse. Because why not? There's no harm done. And these tubes are the result of I think I built, it was a 2 V8s. I built 2 V8s and these are leftovers. So I always make more tubes that I need. And well, and we are going to first do the intake. The intake goes first to the central, come on, wow, it's so dark, to the central inlet of the switch. But the problem is that it's not a straight affair. I mean, with the inlet, it's a straight affair, but then the two outlets for the cylinders need to be slightly bent. So let's do this first, the inlet. Let's see if I have a tube that's long enough. This one is going to do. So it needs to come to here and then continues its way out here. Now we need to cut about this much. Okay, it's in, sits nice and flush. Now let's see how much do we need till it meets the other one. So first we determine how much we need to cut the vertical one. Usually make just tiny mark. Come on. There we go. And of course the same with this one. Okay. Now I take both out. Find the marking, of course. Where is it? Ah, here it is. Yeah, it's rigid tubing. Absolutely. So it cannot pop off. And I'll always make a cut like this, because when you put it all together, it needs room to clear the other tube. So okay, I used the wrong tube. It's this one. I need to use the short one. I use the long tube and I need to use the short one. There we go. Okay. Intake. Now we need a tube that goes out. We cut a little ridge. And in it goes. There we go. Intake for our engine is done. Now to the hard part. For this, I usually come on. Usually use one of these, or if I feel lucky, I just bend it by hand. So we need 4 tubes that will be part of our outtake. So these are going from the switches to the T-junctions where they split to the cylinders. And while we're at it, we are also going to make some more 90-degree tubes. Okay. I don't have much tubing left, but it'll be enough for today. So this is a candle. I don't know if you can see it. It's lit, and what we're going to do, of course that's the correct order. What we're going to do is, first we need to bend these, so it's basically a shape, something like that, an L shape. Yeah, my desk is like that for very specific reasons. So something like this. Okay. Okay, so we need this kink here to clear the lift arm. The lift arm, that is, see, this lift arm is in the way of the inlet, so we need to have a little bend to go around it. And now let's do some 90-degree tubes. So see, this one, is no good. We fucked up. Too close to the fire. So it's all right. We need 8 of this. 5, 6, and 2 more. Okay. 2 more. I mean, they are way too long, of course. When we cut them to size, they will be so much shorter. But it's easier to bend them when you have something to grab on. The longer the tube you can grab on, the nicer the bend will be. Okay. There we go. Now we need to cut this up. Okay. First, the short ones. Okay. Okay. We're going to need to fire up the candle once again, but this will be for the last tube. Okay. Very well. Very well. So first tube, I'm going to make a little higher than the intake. That's a little higher than the intake. And of course it meets the T-piece somewhere here, so it needs to be very short. And the T-piece, I'm going to cut here, insert onto the inlet. There we go, you see? Oh, it's so hard to see. Man, hold on. Let me see if I can shine some light with the phone. How much light do you need here? Oh my god. I don't know how good it is to see, but should be able to see the bend. I cannot help it. Okay, now let's see how high it needs to be. Okay. So first thing, well, the thing is that these here will, yeah, of course, this tubing is rated for 10 bars of pressure, so it won't pop off. While the rubber, so the silicone Lego tubing will just pop off when there's too much pressure, and we don't want that. Okay. Next side. Same procedure. Now we need to see that it's about the same height. We want symmetry. Well, nothing lasts forever. There we go. It's not really that easy as you think, because the problem is that each and every one of these tubes is slightly different, and that's the cause of the problem. If I would somehow 3D print them all the same, then of course it would be just copying, but that's not how it works. Okay. Electronics. What kind of electronics? This is a very analog affair. Okay. Now we know the exact length of this. Yeah, well, I don't want a bad result. It's for me. I'm not doing primarily. I didn't start making the engines just to make money. Sure, it is some money, but I am. What makes me happy is if people enjoy the engines, if they use them to power their models, or they just enjoy them as they are, running them from time to time. And for this, and it also needs to look the part. Aesthetics is an important part. So I could just randomly do some tubing, but I like it if the tubing looks nice. Hmm. Very nice. That's what I want to hear. Oh yeah. Now that you mention it, we want pictures and video, please. I would love to see them. So now we do need the candle once more. Yeah, now you let the rabbit out of the sack. We want to see it. LPE means Lego Pneumatic Engine. So I'm keeping some of those for later, but I'm throwing most of them away. There we go. The engine is done. Okay, not sure. Maybe I fucked something up with the timing. Let's see. My not use a little more advanced. That's strange. No. Let's try to write. From the silicone spray bottle. That's usually cool. Oh. Okay, let's see where the problem is. Troubleshooting is always fun. I suspect I know where the problem is, but let's see. So I need to go through some pictures of the engine. And let's quickly determine where the problem lies. Okay. Well, timing looks alright. Let's see if I have timing somewhere on the picture. So it's like that. Well, the timing as we have it now is perfect. Where else could the problem be? Tubing is also right. Well, no, it's not. I'm just checking. Tubing is as it should be. Tubing is proper. Could be the crank. Let me check the crank. Let me check the crankshaft. Okay. Nope, the crankshaft is alright. Okay. Then I do not know what the problem is. Could be that it just wants a little bit more pressure for the first run, so that everything gets a nice run in, and then it would run. This isn't going to happen today, because I need to take it down to the air compressor and run it on the air compressor. But I'm absolutely too tired today to do any of that. It's, oh god, it's 11:30 already. So I'll call the stream today. It was nice. We managed to build an engine. I will see what the problem is tomorrow, and I will report it on tomorrow's stream. And tomorrow we are continuing with the charter. So this is done, and tomorrow is charter time again. So with this, good night, and I see you tomorrow.